Okay, let's run through this Mei M2 question, January 2011, question 1. I've already done most of the working because it's fiddly. You'll see the question is fairly straightforward, but it's just a case of solving simultaneous equations. Have a look at the parts of the question. That's the first part. Pause the video and read that, and then go on to the second part when you're ready. That's the second. That's the rest of the question. That's it. So for the first part, and I've written this, the necessary working on here because there's very, very little of it. For the first part, we've got to find the maximum possible frictional force. Now, recall that the maximum frictional force is equal to mu times r, where r is the normal reaction. Now, this is an object of mass 2.5 at rest on a slope, so we can easily find the normal reaction, and that's what I've done at the top here. By resolving perpendicular to the plane, we're able to find the normal reaction, and in a general problem, r is mg cos alpha. In this case, that becomes 2.5g cos alpha. This is only the case because there's no other forces with components perpendicular to the plane apart from r and the component of the weight. So mu r works out to be 16.66. Pause the video and check that yourself if you need to. I'm using the fact that cos alpha is 0.8 for that. We'll need sine alpha for the next bit, because we're going to check now whether A will remain at rest, whether this object will remain at rest. Now it will remain at rest if the maximum friction, 16.66, is bigger than it's needed to hold the object at rest on the plane, and the force that the friction is working against will be mg sine theta, or 2.5g sine theta, 2.5g times 0.6 then, because we know the sine alpha I should have called it. Because we know the cos of alpha, it's easy to find the sine of alpha. And because cos was 0.8, which is 4/5, sine is exactly 3/5 from a 3-4-5 triangle. So the weight component down the plane is mg sine alpha, which works out to be 2.5g times 0.6, 14.7 newtons. The maximum friction acting up the plane, if it was needed, would be 16.66 newtons. So, because 16.66 is easily bigger than the component of the weight down the plane, it will remain at rest. And I've shown in red the marks for that part of the question. 6 marks in total. A method mark, well, a single mark for writing down the value of sine alpha, a method mark for resolving perpendicular to the plane, and then accuracy marks for basically calculating max friction and the weight component and concluding that it remains at rest. On with the next part. This part of the question was to do with the collision, which I've shown in the bottom corner here, between the object coming down the plane at a speed of 16 and the stationary object. And the main working here is on the right, coming down here, and this is really why I've already worked this out before I recorded the video, because I don't think it's very instructive to watch me solving two linear simultaneous equations. That's all that's going on here. Just take a moment to check that the equation for the conservation of momentum down the plane and the equation for Newton's experimental law down the plane, just check that you agree with those equations, and the rest of these steps simply involve solving those simultaneous equations. And you might like to check by pausing the video that you can get V1 is 2, V2 is 8.4. So the velocity of A after the collision is 8.4 down the plane. Right. Oh, there's one more thing on this page that I just draw your attention to. We've just found the velocities after the collision, and the question goes on to ask for the impulse on B. Well, impulse is change in momentum. So we need to find the change in momentum of the B object. Now the velocity after collision was 2 for B down the plane. The velocity before collision was 16. So putting those into the equation, I equals mv minus mu. We get 1.5, which is the mass, times minus 14, which gives us an impulse of minus 21. In other words, 21 Newton seconds up the plane. So that's part 3, that calculate the impulse on B. The final part of the question is just asking us for what length of time after the collision does A slide, the bottom one, slide before it comes to a halt, before it comes to rest. There's 2 ways of doing that. This is the way that first sprang to mind, so this is the way I've just done it. And that's by working out the acceleration, or the deceleration, if you like. It's going down the plane at the moment, but it's decelerating. So work out the acceleration up the plane, which will give you the deceleration down the plane. So I've worked out the difference between the frictional force, 16.66, minus mg sine alpha. That's alpha then. And that frictional force I put equal to F equals ma. I'm using F equals ma. I've worked out the magnitude of the acceleration, 0.784. That acceleration is up the plane. So as far as motion down the plane goes, using the equation v equals u plus at now, v is 0, u is 8.4, a is minus 0.784, and we've got to find time. And that gives us a time of 10.7 seconds for the final bit of the question. There was just 3 marks for that part of the question. Basically, no, there's 4 marks, I can't count. 1 method mark, 1 mark for using v equals u plus at, and 2 marks for finding the correct value of t, of time. Right, just checking that I've been clear with the mark allocation for the rest of it. I don't think I went through this. The mark allocation for the main part of the question, for these, for finding the velocities after they collide, there was an M1A1 for the conservation of linear momentum, and likewise M1A1 for Newton's experimental law, and 2 accuracy marks for finding the velocities. For finding the impulse, 1 method mark for the impulse's change in momentum, 1 for finding the impulse, and 1 for stating the significance of the minus sign as meaning it's up the plane. And that, I think, is it. Did I, just going back to the very first part, yeah, we talked about the method marks for that. So that's January 11, Mei M2, question 1. Just going to the final page, which gives information on the Further Maths support program. Thanks for listening.